We'll move on to the next talk. This is going to be by Dr. Srinivas, Bangalore. And he's going to talk about maximizing user experience in enterprise virtual agents. So from pure linguists to applied NLP is where we are headed. So Dr. Srinivas Bangalore is a principal technical staff member at AT&T Labs Research. He was awarded the AT&T Science and Technology Medal in 2009 for technical leadership and innovative contributions in spoken language technology and services. So he works in the areas of natural language processing, machine translation, and speech understanding. Srinivas, the stage is yours.
Thank you, Vasudev. Can you see the screen?
Yes, we can see the screen.
Thank you, Vasu. Thank you, BTG, and everybody there for inviting me on this wonderful occasion to celebrate Professor Sangal. Rajesh literally took away many of the words that I was going to express in terms of how rich of an environment Professor Sangal had provided all of us under his tutelage. And I'm going to spend a few moments, just like Rajesh, reminiscing some of the past. To begin with, I actually want to thank Nishaji, partly because Nishaji has given Rajiv Sangal to the community and facilitated everything that he has done in terms of all the adventures from, NLP, from the universal human values that he's launched into. We can see some of that force behind all of those adventures in Nishaji, from building out Karak charts to her warm smile and the hospitality that I have been privy to. She's been the driving force, and no better words than their own daughter summarizing essentially how successful their teamwork has been over the years. So thank you, Nishaji. If you're there, you deserve a lot. Now, from my association with Professor Sangal, like Rajesh, I trace back my association to IIT Kanpur days. Like Rajesh, I cherished some of the debates that I've had with him, and no idea was beyond a debate. And Vinitji and Rajivji have facilitated such an environment. And it had taught me to question most of the populist ideas. And back in those days, GB was the populist idea. I recall Professor Patnaik and Rajivji and others debating vigorously on LFG, Paninian theories, how different Karaks are relative to the structural notions that Rajesh had alluded to. And subsequent to that, my early research career days, he took me under his wing, so to speak, and included me in germinating what Indian NLP is today. I recall the first winter workshop that we did in AUK, BC, back in Anna University. That was 20 years back. And like Professor Raj Reddy said, a handful of people were known for Indian NLP. And it's gratifying to find out that some of the students who attended those schools, the conferences, they have graduated, they're researchers in many of the leading institutions in the world, and continue to pursue NLP with passion. So it wouldn't have happened without the sort of foresight of those times from Professor Sangal. And most recently, I've been engaged in the national initiatives, the speech-to-speech translation project that has been launched. And even recently, he and I had a conversation of how to go about measuring success which is an important criteria when such national initiatives are launched. So to take terms from a modern terminology, I was pre-trained in IITK and perhaps fine-tuned at UPenn under Professor Joshi. So thank you, Dr. Sangal, for all that you've done for us. Now for my talk itself. Unlike Vasudev's introduction, I'm no longer at IIT, at AT&T Research Labs. I am leading a research unit in a small company called Interactions, and the purpose of Interactions is to design enterprise virtual agents. Many of you know personal agents that you may be talking to Siri or Amazon Alexa and so forth. What Interactions does is to design enterprise virtual agents to companies like Apple and AT&T and other large enterprises. In my experience and research division, a nagging problem is how do we bring technology and its advances to maximize user experience? How eventually, instead of putting people through the inadequacies of technology and delivering a frustrating user experience, how do you improve that end user goal? Because eventually a user calls into a system to get a task done. They don't care how accurate a parser is working. So that has been a challenge. And in this talk, I will try to allude to some of those advances and some challenges along the way. So to recap some of the evolutions that have happened over the last 15, 20 years, the speech and language solution space has evolved dramatically, so to speak, in the last 30 years or so. Right from improving speech recognition accuracy to understanding natural language technology to a point where we can deliver systems that have meaningful value in people's lives. And you can see that in your personal assistants that you use. Along the way, there is a dramatic shift in the technology that underlies these advances. And also the increased availability of data and the open source software has ushered in this new era where usable systems can be put together without much of a skills requirement, as opposed to the 80s where even building a lab prototype required a heavy duty skill. So along the solution dimension, there is also an evolution in the conversational technology itself. From the 60s, where we discussed formal grammars and tried to mathematical form models of language, to the 80s and the early 90s, where we started wondering about how to encode linguistic ideas that people like Rajesh have talked about into computational grammars. And while we call them rule-based systems, later on, with the availability of data, we have created a new generation of systems that are driven based on data. We had generative models, discriminative models, and most recently, nonlinear DNN-based models, deep neural network-based models that have relied on data-driven data availability. Now, coincidentally, and not surprisingly, the computation, which is price and storage for a memory usage, has decreased dramatically, and so is the computation. Computation has increased dramatically, and both these factors have come into play to usher in this data-driven approaches. And more, we see models that are created with high computational requirements and with large amounts of data, and it's commonplace to see that. However, there is a growing cost aspect on data annotation. We've seen that in the tree bank annotations that Deeptiji talked about. So the question now is, how do you combine all of these into some meaningful system that delivers useful information to people and sort of changes the society in a ways that we can go beyond the lab, from lab prototypes to realities in production. So I'll be talking about conversational systems. These are systems that are dialogue systems that bring together a multitude of technologies together, and you will see a delicate balance of all of these technologies coming together to deliver something useful. Now, as I mentioned, we have the consumer virtual agents. Many of you may have experienced. These are conversational systems from my unpaid customers, so the expectations of the accuracy is vastly different. They are used to deliver non-critical requests, question answering, or the directions to some place or so forth. They're also driven by smart speakers, mostly at home or devices that you hold in your hand. And so there is far few microphone variabilities coming into the picture. And mostly they are single-turn conversations. They don't go into deep conversations, task-oriented dialogues. But however, there is a broad range of requests, people asking about factoids, directions, various prices, or various question answer systems are built around that. In contrast, the enterprise virtual agents are driven based by paying customers. They have a service from an enterprise. They're calling in with some critical request, be it a technical support, be it a billing issue, be it a new service that they would like to purchase. So there are critical requests. There are unconstrained microphone variability because they're calling from a variety of different sources. And mostly they cannot be solved in a single turn. They are a multi-turn conversations that require deep expertise, and domain-specific information needs to be available to back those requests. So just to contrast those two. Now, in a first step in the process of understanding the user, you may want to extract the acoustic attributes. What is the speaker ID? Do we know the speaker before? Do we know their age, their gender? What is the emotion status of that speaker in the conversation, and so forth? Now, many of these traditionally we would have thought of as, well, there would be a feature extraction from speech that would be PLP features or MFCC features and so forth. And then subsequent to that, there would be some sort of classification, either typically a linear classification model or a GMM-based model that would provide us with the label, whether it's a particular age of a person or a gender of a person and so forth. Increasingly, we see a convergence of all of these into certain architectures and networks facilitate automatic interaction followed by the classification layered on top of that. Can I mute everybody? Noise on the bridge.
So your voice is breaking. So
yeah, I think there is a lot of noise on the Zoom bridge. Not sure whether that's coming from my side or from the
yeah, it's Kanakadurga.
Thank you. In a similar sort of approach, you would see that a speech recognition has certainly advanced over the last 20 years, most recently with DNN-based technologies. And with the increased amount of data, you can see the error rates dropping significantly. And we used to build conventional GMM, HMM models, and subsequently moved on to hybrid DNN-based HMM models, where nonlinear classifiers were used to predict the states of the HMM. And more recently, we have moved on to end-to-end speech recognition systems where there is no explicit encoding of features, there is no explicit encoding of a language model even. We directly predict what are known as BPEs, which are parts or subword units, directly from the speech signal. And these advances are surprising in one sense, partly because you have computational power and the availability of data to a point where some of the multilingual aspects that we thought we require specialized knowledge are being mined out, so to speak, from data directly. Now, there are a few challenges along the way. There is a heavy reliance on large data. Now, question becomes, where do we collect that such data? How do we control these systems for specific vocabulary? If there are some specific names of people that we would like to recognize, or name places that are not known to the model before. The idea of pronunciation variation is still a nagging problem here, with code switching particularly. And not surprisingly, drift in language. Language is a dynamic object, and language drifts over time. So how do we make sure that these systems are capable of adapting with very little data in one sense? So, there is an extreme example here that I'm going to show you, where typically we would have thought about spoken entity extraction, where we would want to know the name of a person from spoken input directly extracted. And typically we would have thought about doing a speech recognition followed by a named entity tagging, and subsequent to that, a normalization step to get the first name, last name. But here is an example where one can go about doing one step all the way from speech recognition to entity extraction in one step. And let me play the audio.
S as in Sam, K as in keep, I as in Ina, B as in boy, O as in over.
So, and traditionally we would do this in two steps. We would have a speech recognizer produce these words, and subsequent to that, do some entity extraction on top of that. Now, if we...
S as in Sam, K as in keep,
Sorry.
I as in Ina, B as in...
So we could go directly from the feature, from the signal directly to the words. And you see some of the results that we see doing such a thing in first name, last name, full name, addresses. You see the one-step process improving on the conventional two-step process to a point where even human recognition can be surpassed, partly because names are challenging for humans to recognize. Right? So these are advances that have been made in the recent past because of availability of computation and data. Now let's talk about natural language understanding. Many of you know that there are many different levels at which understanding or semantics can be extracted out of the text or speech signal. It could be a simple binary distinction to a rich multi-level predicate argument structure, as indicated in the last representation. Right? Now, in the old days, we would design lexical representations that were interpretable. Many different computational grammar frameworks have been designed to represent the lexicon with syntax, semantics in the lexicon. And you see some examples, well-known examples here, including Paninian grammar. But increasingly, we are seeing contextualized representations that are learned from very large data sets. This is GPT-3 representations of lexicon, not talked about as if they are lexical representations, but effectively words are represented in very high dimensional space, and they have been learned from very large corpora with contextualized information that spans not just the sentence, but eventually the whole text in which they appear. And these representations are surprisingly good in terms of doing few shot meaning how quickly can you use this representation for a particular task. And interestingly, even zero shot learning, where you can not expose the system to any domain specific information, and yet they perform reasonably well. Of course, there is still a gap. Now, the challenge for the community is how do we use the work that was done in the 90s with the work that is being done in the recent past to do even better than what a purely data-driven system does. So to caricature some of the advances, I'd like to say we're moving to a world where we don't think about the how, but we have to think about the what. In the classical systems, we would think about syntactic analysis followed by semantic analysis, and then there would be a rule-based inference system that would extract meaningful information out of the text or speech. But today, many of the systems that are being designed are of this nature. We would have a pre-trained contextual representation, whether from text or from speech, and then they would have a small amount of data that's specific to the task. The lexical representations are fine-tuned on those task-specific data. And subsequent to that, there is a classification step, an inference step that is driven based on those task-specific lexical representations. So it's a dramatic shift in one sense. And we will see the limits. I know there is a panel discussion. Would love to be a participant in that. Unfortunately, it's beyond my time zone here, but I'll catch up on the recordings. Now, despite all of that advances, NLU is not perfect. NLU on ASR is even more imperfect, partly because of error amplification. And instead of frustrating the user by the limits of technology, what if you had a human assistance in real time along the way? Now, if you were to embed a human in the process where NLU systems, when they are less confident, can bounce off that signal to a human being who will listen to it and understand it and provide the nudge that the technology needs so as to not frustrate the user eventually. And such systems are being done by companies like Interactions, which I am part of. There are implications, however, to what kind of semantic representations can be done reasonably fast in real time in place without having a user impact, because you don't want to annotate data at the level a linguist would recommend, because it would take much longer and that would have consequences on user experience as well. So designing the appropriate level of semantic detail in real-time annotation with low-skill labor is a challenge in this proposition. Finally, dialogue management. Most of the systems that are designed for in the enterprise space are flow-based, if then else kind of systems, pretty controlled. In many of the cases, it is in consultation with enterprise customers, but there are interestingly systems that are information state update kind of systems where they fill out a frame or use an ontology of the domain to drive the dialogue. But even in dialogue, there are end-to-end neural models that are coming to the fore, partly not successful yet, partly because the enterprise customers require control that these neural models don't necessarily provide. Once we design systems in which you can configure them with the desired level of control, then I expect the end-to-end neural models also to take off in dialogue management. Finally, nothing is complete without metrics. There are many, many different ways in which you can design metrics to evaluate user experience. It could be purely technology-driven metrics, or intrinsic or extrinsic metrics, or maybe even business level metrics. So designing a unified metric is fairly important, but I'm not sure if everybody will agree on one unified metric for this particular task because of many, many different stakeholders in the process. Finally, there is a role for you and I as end users of these systems. Interestingly, human-human interactions is remarkably different from human-machine interaction. If you measure the number of turns in a human-machine interactions, it's far shorter than human-human conversations. The kinds of words that are used, the kinds of syntactic expressions that are used in human-machine conversations are vastly different, partly because we believe that these machines are not as intelligent, and what's the point in telling them the whole story, right? So we need you to improve these systems so that the next generation of systems that we build would be as intelligent as a human conversation would be. So finally, those were my talk points, but coming back to Professor Sangal's journey and his idea of human values, I'm not as familiar as I am about his explorations in natural language processing. But I believe that his endeavor is to maximize human experience through the Human Values project that he's launched into. So thank you, Professor Sangal, and look forward to the next chapter in your journey. Thank you.
Thank you, Srinivas. Wonderful talk. Any questions? Any comments? Okay.
Hi, Srinivas. I have a question. So, uh, if a user in a professional settings, if a user is using if he is constructing a sentence with a ill-formed structure, so if the virtual agent cannot identify the intent, how do you handle it? I mean, even though the thing what he want to mean relates to some intent, but if it is not hitting, how do you handle the case?
Yeah, it's a good question. So many of the NLP systems that we build today have a notion of a confidence. Think about it as a probabilistic measure of how confident is the system in predicting that particular intent. Now, just in case the system is not confident, there is a threshold which says, well, this intent, don't believe in it. We have a rejection, at which point that falls back to humans in the loop. And the human listens to the audio and discerns that intent in real time, right? So that not to frustrate the user at the end of the day.
So how's human learning, or what will be the process after that? I mean, will companies educate or will the companies tell the users how to use the VA, or will it be the other way process? The VA will be improving because this can't go to human every time. Or how do you make people understand how the VA is built or how utterances are so that the intent matching is higher?
Right. So one of the classical problems is that we used to adapt ourselves to work with the system. And because of the inadequacies of technology, we would adapt ourselves, construct sentences, and get a task done because technology was not perfect. And we want to move away from that. We want to move away to a point where the system adapts to the user as opposed to user adapting to the system. And what perhaps is not clear is that when technology fails because of a difficult, noisy environment where speech recognition was imperfect, or the construction was ill-formed and therefore intent recognition was imperfect, we have humans in the loop, but the user doesn't know that they are talking to humans behind the scene. They still experience technology, but humans are driving the technology. And next time around, when such a situation happens, then the technology can be improved and it will take over. So over time, technology improves and the user gets a better experience rather than user adapting to the system.
Thank you.
Thank you. Any other questions, comments? Srinivas is from ITs. My question to you is in your interactions, how often have they fallen back to the human?
Hey, I can't hear you well.
I'm asking, how often do they fall back to the human? So it's in the interacting with the machine. And then when things don't get going, then the human assess.
Vasudev, can you repeat that question? The microphone seems to be an issue.
Sir, can you give me some statistic on
Yes.
how many times do they, fall back to the human being to give them an answer?
Right. So today, when we started out, the technology was not as good as it is today. And about 70% of the utterances in a dialogue would fall to the human. Today, with the technology that I just alluded to, about 15% of the utterances fall back to the human. And we are continuing to improve, of course. The volume, to give you an idea, we get about 2 billion transactions a year, of which 15% fall to humans.
Another question is, but we're comparing classical machine learning versus deep learning. Is it just that your backend hardware has improved so much? You're able to, so suppose you looked at the classical environment versus the deep learning environment, would you have seen similar performance improvements? Because everything is learning on the average.
Yes. Well, the thing, I believe there are two, dimensions, as I alluded to. One is, of course, the computational cycles with GPUs being available. We are able to crank a lot more sophisticated architectures in these systems. And along with it, the availability of data has increased dramatically, right? So both of these coming together, you can design systems that are far outpace some of the assumptions that we used to make in earlier days because of lack of data and because we would make some independence assumptions that no longer need to be made with these nonlinear deep neural network systems. And I believe both are in concert for this sort of improvement.